Today, we'll show you how a single document can hijack an OpenClaw agent and how Xage stops it. AI agents can fetch data, write files, execute code, and make network calls, all on their own. A single prompt injection, like hidden instructions inside a document, can turn a helpful agent into an attacker. Secrets could be exfiltrated, systems could be compromised, and the user would see nothing wrong. Here's how it works. A user asks the agent to fetch and summarize a document. The agent fetches the document, as requested, but it contains hidden instructions that the user can't see. The agent follows those instructions. Create a malicious script on the user's laptop, execute the script, and send the user's credential to the attacker via email. Meanwhile, the user sees a clean summary, not realizing anything malicious has happened. Now, take this example. An OpenClaw agent is connected to Slack via a bot. A user asks it to fetch and summarize a document. It responds with a clean summary, including the project brief, team, timeline, and budget. Everything looks normal. But inside the document, there are hidden instructions. They tell the agent to create a script, run it, and email out the server's environment. Without a checkpoint, the agent might blindly follow those instructions. Opening the attacker's inbox, you will see an email enclosing a file that contains confidential user keys and credentials. This was exfiltrated silently, without the user ever knowing. This is where Xage comes in. Think of it as a security checkpoint for the agent. The agent, in this case OpenClaw, can't take any action without first passing through that checkpoint. Every time it tries to do something, the Xage plugin intercepts the request and evaluates it. If the action is allowed, it goes through. If it's not, it gets blocked and the agent receives an error. And importantly, every decision, whether allowed or denied, is logged with full context. Now let's take the same scenario, but with the Xage Agent Sentry enabled this time. Within the Xage Fabric platform, you can enable an allow list of what the agent is permitted to do. For example, here we have allowed shell execution for basic commands, file read for specific paths, and network requests to our domains. Meanwhile, file writes are set to be denied. With Xage controls enabled, let's revisit the original example. The user asks the agent to fetch and summarize the document, which it does. But this time, the agent reports that it's unable to create the script, blocking the attack execution. Now let's look at the audit logs, starting with web fetch. Here you can see everything was logged, including the agent action and the original user prompt. Now let's look at the write audit logs. Here you'll see the same user prompt, same session, but the agent tried to write a shell script to disk. And because file write isn't in the allow list, Xage blocked it. Everything is in the audit log, including who triggered the action, what was attempted, and why it was blocked. With Xage, you control what your agents are allowed to do. You get full visibility, not just what happened, but why it was allowed or denied, who triggered it, and all the details. Least privilege, policy enforcement, full audit trail, that's how you secure AI agents.